Hi, I'm Sojin Park from MIT, and I'll talk about my vision and future plan. There are two key trends in computing. The amount of data we use is increasing exponentially, and we store and process those data in data centers. The biggest benefit of data center computing is the ability to run large-scale applications that harness hundreds or thousands of servers. However, to use hundreds of servers, an application must execute for relatively long periods of time, seconds or minutes. This is necessary in order to amortize the high cost of coordinating many servers. And frameworks like Spark or Hadoop typically operate on very large block of data to amortize high network latency. So today's interactive applications can operate on large data directly. To answer interactive queries, they must pre-process data for all potential queries so that they don't have to deal with large data interactively. And here comes my research goal. I want to enable massively parallel data-intensive computing even for very short time scale enough to be interactive, or even lower time scale for real-time control applications. I call this vision flash burst parallel computing. In this vision, when an application has a sudden need, it can quickly burst to hundreds or thousands of servers to operate on large data. Thanks to the massive parallelism, the processing finishes instantly. Then applications shrink back to the small scale so that it won't cost a lot more than slow batch processing on average. This flash burst style computing will expand the horizon of the amount of data we can utilize for interactive applications. So this will simplify building interactive data-intensive applications, and also it will benefit many real-time applications, especially that doesn't involve human in the loop. For example, when it detects cybersecurity attack and intrusion, we can do more in-depth analysis and block attack more quickly and accurately. Or we can control swarms of drones with the tons of sensor data coming in real time. I think FlashBurst is a moonshot, and there are many obstacles on the way to realizing FlashBurst in data center. So I've taken two-pronged approach. I first built some key important applications such as analytics and data training. By trying to build these applications, I could confirm that important application will benefit from FlashBurst style computing. Also, I will understand what kinds of system challenges will surface when we move to FlashBurst computing. On the second prong, I improved various parts of distributed systems so that FlashBurst applications can run more efficiently. In the future, I plan to build a complete working FlashBurst platform, and I can imagine several remaining challenges. From the experience of implementing FlashBurst applications, I learned that manually managing coordination among many servers is very complicated and not flexible enough to dynamically scaling. So I need a new programming framework which hides the notion of individual server and allow programmers to write applications as if they're writing a sequential program for a single server. And we have some initial progress on this. Logical Process Framework splits Unix process into granular pieces called proclets. The second challenge I want to highlight is speeding up the cold start. To allow real efficient flash burst, we should be able to burst to new sets of servers as well. One possibility is leveraging language-based protections instead of hardware protections. The last challenge I want to highlight is debugging. First, FlashBurst is very sensitive to tail latencies, so we must fix all of the tail latency sources. But analyzing the root cause of tail latency is very difficult since it occurs occasionally. So we need a new automatic tail latency finder. Second, with the dynamically moving proclets, we can use GDB for debugging our logical process anymore. So we need a new tool that can accommodate these bursting pieces of code. On the other hand, I'm interested in finding more interesting use cases of FlashBurst, especially on security and safety. And I think FlashBurst will open up new interesting opportunities to save energy. First, we no longer have to process data for all potential queries. Second, we can use slower but energy efficient hardware for scaling to more of them. In conclusion, I will explore challenges and potentials of this new large-scale computing paradigm. Thank you.